So we have already done with the hard work. What we did, we went through each and every event and we calculated what our per kilometer for that event. We also calculated the distance covered in that event and the total energy consumed in that event. And now let's see how much total energy we consumed when we went through this driving cycle. So how much distance that we have traveled, it is nothing but the summation of this column, and we got it here, which is 672 meter we have traveled. So if I ask you how much energy that you consumed while traveling 672 meter, then what you will do, you will just add this value. So just add this value, which you will say we just consumed 18.73, but this is a theoretical number that you got it. What you assume that during deceleration mode, when you are, let's say, coming from 25 kmph to 15 kmph, the energy went from motor to battery, which is 8 watt hour. You consider the 100% energy went back to the battery. But in a practical sense, this will be only 20%. And this term has a name called regenerative braking system. So here we consider 100% of regenerative. But in a all practical sense, it is just a 20%. Only the few people or a company has achieved 35% of regenerative braking, and this could be a research topic for you to find how to achieve 100% of regenerative. But till that, the practical regenerative braking that we can assume 20%. So that's what I have assumed here. So the regenerative level that I assumed 20%. And now if you want to recalculate what is total energy consumed while traveling 672 with 20% regenerative, then what I did, I just separately add the positive value and then separately I add the negative value. And if I have to calculate total energy consumed, then I will add this positive value plus the negative value, but the negative value I am just considering 20% only. So which is 65.74, and that's what this number you got it. But for 100%, you have 18.73, which we got it previously here. Let's put back this 20%. So now with 20% regenerative braking, the total energy that we consumed is 65.74. Now let's go ahead and then calculate watt hour per kilometer. So we know what is total energy consumed and we know how much distance we have traveled, which is 672 meter. If we just divide this number or what total watt hour to the distance that we travel, then we will get watt hour per kilometer. So that's what we have done. I converted this distance to kilometer and then I got this value 97.83. So let's say if you and me driving a car with this driving pattern, then on an average we will consume 97.83 watt hour in 1 kilometer. Now if we know this value, then we can calculate the range of our vehicle, and for that we need to know the battery capacity in our vehicle. And the way we define battery capacity in electric vehicle, we use the unit called kilowatt hour. And for typical four-wheeler electric vehicle, I have considered 30.2 kilowatt hour battery capacity. So now if I just have to divide this number by watt hour per kilometer, then I able to know how much kilometer I can go. So let's divide this number. So this number is in kilowatt hour. Let's multiply it by 1000 to convert in watt hour and then divide by this number. So we can go 308.67 kilometer, but this is again a theoretical value, or I would say a superficial value, because the energy which is stored in the battery will not converted 100% in moving your vehicle. There are a few percent of that energy will be wasted by the motor. That is one thing. And second thing, you cannot take out the 100% energy from the battery. Let's say you have stored 30.2 kilowatt hour. You cannot extract 30.2 kilowatt hour energy from the battery. Only certain percentage of the energy you can able to extract it, and that is we define as a depth of discharge. So only the 85% of the energy in this case you are going to extract from the battery, and that's what I have defined here, the depth of discharge. And separately I have defined motor plus control efficiency, which is 85%. So though we have considered 30.2 kilowatt hour energy which is available for moving the car, which is not the true, it is now just how much available, this multiplied by this multiplied by this. So now the energy which is left for us to move the car is only 21.81, and I have to calculate range on this energy. So let's divide this number. So first I will multiply it by 1000 and then divide by this number. So we got 2 to 3 kilometer we can go, and this is the number that you can see here. So congratulations to you once again, you have calculated the range of the vehicle using this driving pattern. And this is just an educated estimation. For you this number could be higher and could be lower. Let's say you are driver, then this number could be very less because you are suddenly accelerating and then suddenly decelerating. And for me this number could be very higher because I am smoothly accelerating and then decelerating. But on an average we can say that if I charge my vehicle, then I can go 2 to 3 kilometer.